Assalamualaikum warahmatullahi wabarakatuh and good morning everybody. We from group of 7 will explain our material on thermodynamic chemistry. Our group consists of Nurmala Saridila, Wahyu Yusufdullah and Arianti Soleman. I am the fifth speaker on behalf of Nurmala Saridila. In the material thermodynamic chemistry that we will discuss is about potential energy diagrams, heat and change is page, thermometry, Hess law, bond discussion energy and entropy, Gibbs free energy and spontaneous reaction. As shown in the picture, in the following figure is a diagram of the potential energy for an exothermic reaction. Baik. Which is on the vertical line is potential energy, and which is on the horizontal line is time. Dan pada garis yang melengkung di atas terdapat aktivitas kompleks atau energi potensial kompleks yang teraktivitas. A is jumlah energi yang teraktivasi. PE and PEP is the potential energy of the reaction and product. Is the delta H the change in heat of reaction. Next will be explained in the second speaker as Arianti Soleman. Thank you.
I want to skip Hayes law. The first thing I want to tell you about what is thermochemistry. Thermochemistry is talk about physical changes or chemical changes related to the heat, right? The heat involved. So the number one is Hess law. I will talk about Hess law right here. From the chart or from the picture in right here, you can see in the reaction A goes to reaction B, and in reaction B goes to reaction C, and reaction C goes to reaction A again. This is like spherical, you can see, and everything that delta H 1, 2, and 3, you can see from this picture, very clear, right? Yes, we call that this one is enthalpy changes. H, the letter H, we call that enthalpy, and then delta is delta, which means changes. For example, we talk about this reaction, which means reaction A goes to reaction B. There are changes between that process, right? Which means process A goes to process B, right? Involve the enthalpy changes. So, and below you can see some kind of equations. With this equation, you can find out the answer when you have a problem and you're going to solve it. You will you better using this equation. It's make easy to you to solve everything, solve a couple of equation related to the Hess law. This is delta H1. You can see delta H1 equal to, because this process is spherical, A goes to B, B goes to C, and C goes to A, which means you can you can make equation like this. Delta H1 equal to delta H3 minus delta H2, and same kind of delta H2, it is equal to minus in right here, like a rearrange of equation. Sometimes we call that exothermic or endothermic process. Minus, which means exothermic process, right? Heat spread to the outside. Heat spread to outside, we call that exothermic process. But when heat is absorbed from the system to from outside to the system, which means we call that endothermic process, right? And same thing, H3 equal to enthalpy changes 3 equal to enthalpy changes 1 plus enthalpy changes 2. And you can see also it is more simple. They make it simple from the picture in right side. A, B, C, A, C, B. This is same with in the top. So the next pages is bond dissociation energy. Dissociation energy. If we talk about in chemistry, we talk about bond, which means there are some kind of bond with their energy level, which means if their bond is different between molecule hydrogen, yes, and oxygen with hydrogen, their bond energy is so different. You can see the difference between molecule hydrogen and molecule hydrogen, their bond dissociation energy is 40,035, but in OH, their bond dissociation energy is 4,139. Yes, the difference we can see directly, right? In H2, it is 435, and OH 435, and so on and so on. They are so different. You can see this is very clear. Okay. And next. I think this is my job. I'm already finished it. So I hope you enjoy with my explanation. And yes, thank you very much.
Okay, I explained about entropy, free energy gifts, and the spontaneous reaction. For the fields, entropy. Entropy is a thermodynamic quantity that measures the energy in the system per unit temperatures that cannot be used to do work. The entropy of a system needs to be measured to determine that energy cannot be used to carry out work on thermodynamic process. For free energy gifts, in thermodynamics, the free energy gives is a thermodynamic potential, which can be used to calculate the maximum reversible work that can be performed by a thermodynamic system. At constant temperature and pressure, isothermal, isobaric. Just as in mechanics, where the reduction in the potential energy is defined as the maximum work that can be done, different potential holds different meanings. And the last, in thermodynamics, a spontaneous process is a process that occurs without any outside input to the system. A more technical definition is the time evolution of a system in which it releases free energy and moves to a lower energy state and is more thermodynamically stable. Yes, this is my uh, opinion or entropy, free energy gives, and spontaneous reaction. Thank you for your attention. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.